Previously on CSIS 2470.
These two pieces right here, where I'm overriding a functionality, a method to do something different, that's polymorphism. It's an animal taking on the form of a bird and doing the thing that birds do. Whereas if I made a dog, it would be taking on the form of a dog, doing the things that dogs do, barking and running, right? Polymorphism, done. Inheritance, well, it's this, right? Inheriting from the parent class or the superclass. Class bird extends animal. That's it. That's all you need to do to make a class inherit from another class. And when you do that, it then becomes a parent-child or a super-sub relationship, okay? And so now, why would you do that? Well, because I don't want to copy and paste animal and then just add one or two things to it to make a bird, and then copy and paste it again and add some things for a dog and so forth. So I can just extend animal, and that gives me everything in the animal. Then I can add extra stuff, right? I can put in a wingspan. I can put in more variables. And the ones that the bird, don't know how to handle, I give to my parents. Same with the two-string. The things I don't know how to deal with, or the things I want to get from my parent, I just grab them from my parent. And then I tack everything else on that's specific to the bird. So that's inheritance. Okay, what's this encapsulation and this abstraction business, right? For that, I'm going to just, outside of all this work we're doing here, do a quick little thing here, a function that's nothing to do with classes or objects. And this function is called add, and it takes in two numbers, okay? And let's fix that there. These numbers, who knows where they're coming from? Maybe they're coming from a prompt. In fact, let's do it as a prompt, and I'll show you why in a minute. In fact, I'll show you right now. Let's just return, or we'll even just do console.log x plus y, all right? Well, let me show you what happens when we do this. Let's refresh, and I'm going to say the number 10 and the number 20. Now, you might expect the answer to be 30, but it will not be. It will be 1020 right here. The reason it's 1020 is because when you enter in a prompt, or a web form for that matter, it assumes it's a string, right? And so these are strings, so I have to turn them into integers. And the way you do that, you can use, there's lots of ways, but we'll just use parseInt and that. And I think we've talked about this previously, parseInt y. So what this means is take this x, and if it looks like a number, turn it into an integer, right? And if this looks like a number, turn it into an integer. So now when we refresh it, I put 10 and 20, I will get 30 this time. Okay, now I did all of this to demonstrate the idea of abstraction. Simply put, abstraction is kind of like when you drive your car. You don't have to be an auto mechanic to know that if you push on the long skinny pedal, the car will move forward, and that if you push on the wider pedal, the car will stop, right? The accelerator and the brake. Now, an auto mechanic does understand those things, and even, quote, lay people who aren't auto mechanics maybe understand a little bit how that works, but you don't have to, right? You don't have to understand why when you put your key in and you twist it, it starts the car. You don't have to understand any of that. Think of like a remote control on your TV. You push a button on the remote and something happens on your TV. You don't have to understand how it happens, what goes on in the actual computer of the remote, and what beam of light that gets sent to your TV or whatever. You don't have to understand any of that. That idea is abstraction. It's hiding the complexities from you. And so here we are, we have a simple function that has this complexity of converting a number or a string into a number and then printing it out or returning it or whatever. Well, all you have to know as a programmer is just line 63. Call add, put in two numbers. The end. That's all you have to know. You don't have to understand any of this. You don't have to see it. This could be in another file. It could be in a library that you don't even see. It could be anything. That idea is abstraction, hiding the information from you. Okay? So the reason I just chose a simple function is because that's pretty much how all functions work. I always treat functions, or I say functions are like a magic box. I pass in some parameter, we hand it off into this magic box, and then it sends me some output. Now let's put parentheses there because that matches the way we write our functions, right? But whatever the heck happens in here, or curly braces, maybe better written, whatever goes on in there, who cares? I have no idea. Doesn't matter. I might have an idea because I wrote it, but I don't necessarily. Take prompt, for example. I have no idea what's going on in the back end with prompt, right? All I know is I put in a phrase, and when I refresh the page, it will make this little box here that I have no idea how it makes that box. And I know that if I type in a number, it will take that and put it into the variable. I have no idea how it takes that number and returns it. I have no idea. That's all abstraction, okay? All right, so that's abstraction. Well, that's happening in our class, right? The get age function, not much going on there, but let's look at the set age function, right? When we set an age, we don't need to understand the complexities of what's going on there. There's error trapping, and again, this is a very simple error trap, but there could be 50 lines of code here that make sure the value is correct. We don't have to know any of that. All we have to know is to set the age. I have to literally just say, let's get rid of this, Tweety.age equals 20 or whatever. That's all I have to do. And that's all I need to know. So that's abstraction. So that's the A from API. We got A, we got P, which is polymorphism. We've got I, which is inheritance. The last one is encapsulation. And encapsulation, we've already been talking about it. We just didn't realize it. And it's this whole private variable business. Okay. The concept is this. I'm going to protect the code or the variables from the coder by not letting them have access to them directly. And so I'm going to make a setter or a getter to allow them to access it indirectly. So this is the key to get into the box here, right? So imagine this is like a treasure chest or something like that, right? And there's stuff in it and you're allowed to get into it, but you have to use the specific key. You're not allowed to directly get to span, right? Or you're not allowed to directly get to age, name, or color. You have to go through the getter or the setter to set it, or the getter to get it. And so that's sort of the key to the little treasure chest of variables or whatever. And so if you want to get it, you have to go through the channels that whoever wrote the class says you have to go through. That's encapsulation. It's just protection. So simply put, the acronym API. A is for abstraction, which is hiding the complexity. That's what abstraction is, hiding complexity. Polymorphism. It's a class that can take on multiple forms. An animal can take on the form of a dog or a bird or a chicken. That's polymorphism. Inheritance is inheriting, like we know you inherited your blue eyes from your mom or whatever, right? You inherit things from your parent. And so we inherit the setters and getters of the age and the name and the color, for example, that the bird inherits that from its parent by using the extends keyword. And then encapsulation is protecting data, protecting these variables by forcing you to use the setters and getters. API. That is it. Okay, the last piece of this now is we're going to look at making a static method. And before we do that, I want to organize this code a little bit better. Now, there is a thing called modules in JavaScript where it lets you import other JavaScript code into your JavaScript file. The only reason I'm not going to show it to you right now is because in order to actually see it in action, you have to run your JavaScript code on a live server. We're not running this on a live server. We're just double clicking it from our desktop and doing a direct file path. So you'll get some weird errors when you do that. Okay. But if you run it through a server, then you can actually do the import and using the module system. But what I'm about to show you is also effective and it works just fine, right? So what I want to do here, I have the animal class. This is the main class here. I want to put that in one file. I want to put the subclass bird in another file, and then a third one to just do all the printing out, right? And so I'm going to come over here and go to my scripts here, JavaScript, get rid of that copy there. I don't need that. So I'm going to keep scripts, and then I'm going to make another one called animal and another one called bird, right? And so just real quick here, I'm in script right now. Script is only going to have this stuff right here. It's going to just have the printouts, right? Okay, and I could have called it printout if I wanted to. And then let's just take the animal and the bird here, and obviously animal is just going to have animal, nothing else, and bird is just going to have the bird stuff right here, like that. Now, obviously, if I'm going to do that, I need to also import them here in my HTML. So we'll do animal, animal, and bird. And if I was going to do dog and whatever, I would just put it here as well. So now let's just make sure I didn't break anything. Refresh, and everything looks like it's working just like it should. But now the code's a little bit more organized, right? And so the script is where I do all the outputting, The animal class, I don't even need to look at it anymore because we built it. It's fully fleshed out. In the real world, that would be true. And all the setters and getters are built and all the error trapping and everything. And so we don't even have to look at that file, right? We just care about our bird file here. And we know that whatever's in animal is all right here, plus everything extra that we've added, right? All our little polymorphism stuff right here. So I'll just call it that, right? It's polymorphism, right? It's taking on the form, the animal's taking on the form of a bird. And this, even the toString method is a polymorphic thing, right? The output of a toString is outputting what a bird outputs, not what an animal outputs, right? So this is even kind of polymorphic, right? These are just setters and getters. The real polymorphism is where you're changing the behavior, right? You're changing the methods of what it can do. And so toString is kind of pushing it, so maybe I'll separate that. In fact, I'll move this up here because toString and constructor functions are the like default behavior, right? When I say new bird, it calls this by default. When I say print bird, it calls this by default, or inner text equals bird, it calls that by default, right? And then this is our bird specific properties. Okay, and these are like we'll just call them object functions or something like that. I don't know. And I'm going to include the toString method with that and put that all on one line there just to make it nice and annoying for people who don't like that style, right? Same thing with this. I prefer this style of code when it's this small, right? Okay, so this is the bird class. Let's make a static class now. Now that we got this all organized here, this is going to have nothing to do with birds. We'll keep the script file. We're going to use that. And I'm going to go ahead and make a new one here. And the new one here is going to be math tools or something like that. I don't know. Okay. So let's go ahead and make that. We'll copy the script here and call it math tools. And we'll open it up in here. Okay. So we've already been exposed to static methods or static classes, static things. There's one that exists in JavaScript called the math class, right? So let's take a look at the documentation here. We go to the MDN documentation right here for JavaScript math class. Here's the math class right here. And you can see it has all these static methods here. Math.abs, which stands for absolute value. And this is ACOS, which I'm assuming is arc cosine. And there's a whole bunch of things here that I'm not a geometry person. I don't know these as well. I mean, I do know cosine and things like this, exponent. And then we have ceiling, which we've looked at before. We have log as in logarithms. We have math.power, that's raising a number to the power, and so on and so forth. And then down here you have static properties. These properties are like, for example, math.pi. Let's just run this and see what we get. We get 3.1415 up to however many digits that is. That's a constant, so I don't have to have that manually in my code anywhere. But notice nowhere did I say let m equal new math and something and then do m.pi, right? I don't have to create an instance of the math class. You just dive right into it. It's just a built-in static class that you can get to without creating an instance of it. Well, you can make your own like that, right? So I have this one called math tools, and let's just do a class called math tools. And let's just do something silly. We'll just do a function called add x comma y semicolon. Or not semicolon, but return int x plus parse int y, right? And so now I have this thing called math tools, and we want to make this a static function. So now that it's static, all I have to do here is console.log math_tools.add 1,2 or whatever. And if we refresh, we got 3, right? This other stuff's coming from the script file. Let's just comment that stuff out for the moment, and we'll go back and refresh it, right? So now we get that 3 there. Now, if I took the static off here, I tried to do that, we get an error because math_tools.add is not a function, because now it's expecting that I have to make a math object, a math tools object. So I'd have to go let m equal math tools as an object, and then I could call m.add and refresh. And of course, I forgot to put the new keyword there, new, and then I refresh. And now it works just fine. But now I have this whole extra step here where I have to completely make a new object and instantiate it. Well, then I'd have to do that every time I wanted to use this math class. Just make it static, and then it's just a whole bunch of tools, right? This is not the kind of thing where you're trying to make an object to model a person or model a thing in the real world. This is where you want to make some sort of utility class. where you just want to have access to something that can do functions, that can calculate things or whatever, right? So we can now go back to this model here, like so. Now we refresh, and it works again, right? So if you want to understand this static idea better, I would recommend looking here at the math class in JavaScript. And there's no need to recreate this because there's already a really cool math class that does it all for you. And look in the documentation for other static classes or other classes that have static methods, I should say, right? And then you don't have to recreate them because there may be a whole idea of a bunch of utilities that you thought, oh, it'd be great to have this set of utilities, and maybe JavaScript's already got it. But this is a simple example. I just want to show it to you so you have the idea of how it works. So that is it for this one. Thanks, as always, for coming to class. Take a look up on the screen there, and if you can answer those questions, you are ready for the quiz, and you've learned everything you need to know from this video. We'll see you next time, folks.